So key value RDDs. So friends, don't forget to subscribe to my channel if you haven't done so. And today we are going to talk about key value RDDs. So whenever you are going to aggregate the value based on a key value, so you are bound to use the key value RDDs. So for example, we have assume, for example, in this example, we need to find the average number of friends by age on some fake social network we have. So for example, we have a data set for on which each person has an age and how many friends they have, and also which may have some other information we might have. Now, if I want to find the aggregate number of friends by age, I mean, if I have to find the average number of friends by age, I have to aggregate somehow all of the friends count for every given age, basically the running count of every given age. So here in this thing, key is the thing we want to have aggregate on. So basically in this case, we have the age as the key, and the values would be the count of friends which we are aggregating. So with the help of this, we will be able to find out the average number of friends broken down by age. For example, and a 20-year-old would have how many average friends? A 33-year-old would have how many average friends? Like that, and so forth. So how do we need to achieve this syntactically? Let's have a look here. So here we are going to show the pair of data in RDD using tuples, which is not just the values but the tuple of two values. So in our previous examples, we have input data wherein every row of that input text file would have a row of data. So basically every row represented a line of input text, a row representing an integer of something. So you can also represent a tuple, and if that tuple contains two objects, then Spark can treat them automatically as a key value pair. And there are some special sort of things which you can do with that information. So let's look at an example. Let's look at this example here. So in this case, we are taking an RDD which contains for 1 bit of information per row and transform into a key value RDD. And all this transformation function is doing is basically map, wherein basically in each line x gets transformed to x comma 1. Yes, so basically we are just adding a 1 to that value, basically to the tuple x1. So basically that is creating a key value pair of x, the original value, and the x is the key and the value 1 for each row. And that's it. There is nothing special beyond that. So basically that's what you are creating a key value RDD with a tuples with a value in it. So you now have a key value RDD basically by storing tuples with two things in them, and you can actually store more complicated object. Like you can still have a tuple wherein a value as a key in some more complex tuple as the value. So you can nest information in structured as complicated you want, but at the end of the day, as long as you have at the top level a key and a value object of some sort, so that counts as a key value RDD. Now what can you do when you have a key value RDD? Let's look about a bunch of things which you can do. One common operations is reduce by key, which provides you an ability to provide any arbitrary function you want, combining values together and then grouping them together by key. So in this example here, take a look at this syntax wherein we are taking the tuple xy here, okay, and transforming it into x plus y. Now this seems to be a little confusing. Stay with me and I will try all the level best to make sure it adds them up to your mind. So surely xy does not represent a key value pair. Bear in mind about this concept. It actually represents the two values which needs to be combined together. So what reduce by key says is I am going to do a function which will accept two values of the same key and how these two things gets combined together in my new RDD. So let's say I want to add up all the total friends count of a particular key, that is the age. Say everyone who is 20 years old. Now for this, like the key number 20, so basically the key 20 never changes, so it automatically gets transferred to my new RDD. But what does change is the value, and which I'm going to aggregate all of together for the key 20. So this function says given two values of the same key, how do I combine them together? In this case I want to add them together, and that will take every value found for the given key and add them all up, two at a time. Okay, well, why two at a time? Well, remember, this might be distributed. Just take them all at once and add them all once together in one function. It has to do a piecemeal, one bit at a time. So we need to tell Spark, given a running total and some new values, how do I combine them together? And that's what this function reduce by key does. This will surely make some more sense when we have a look at the code in due time. Bear with me. We can also do group by key, and when you actually don't want to aggregate all these values for the same key, so you can group them all together into a bigger list. So that's what group by key does. So if I want to collect together all of the values seen for the given key, group by key will return an RDD that is just that. It will give you back key values pair, where for each the unique key and the values would be the list of all values associated with that particular key. We can also do a sort by key, which will basically sort an RDD by key values. Pretty straightforward. And we can also just retrieve the individual keys and values. For that, keys and values function will do that for us. So what are the things others you can do? What are the other things you can do? You can do like SQL joins on the key value RDDs. If you think deeply about it, like this key value RDD is like a more of a NoSQL database, so you can definitely write a SQL style joins because it is like more of a structured database now. So you can write SQL style joins now. One of the other things which you can do is, suppose you are just mapping the values of the key value RDD and you like kind of leaving the keys alone, then it is more efficient to use map values and the flat map values. It's called like map and the flat map. So if you are going to map just the value of the key value RDD, use map values and the flat map values. It will be simpler from the syntactical point of view, and also it will be efficient to use. So let's try to look at the example now. It's good to have a theory and all, but it's good to always have a theory, but when you don't see an example, you don't get the feel of it, so you don't sink it in the concept. So that's my personal experience. So let's go and look at the example now. So we'll look at the friends by age example. Let's imagine, if you will, you have a social network data to play with, and each row of information in our raw input data looks something like this. We have a bunch of comma delimited rows of information. that consists of a user ID number, user's name, user's age, and the number of friends of that user. So you can probably look at the friends data, and it looks like a crazy Star Trek's friend list, as a fancy friend list, and probably a best to avoid. So just to remind you the purpose of why we are doing this again. So basically we are trying to find an average number of friends of a given age. So in this case we have a Will of 33 years age old in our fictitious data, and so is the John Luke, and Will has 385 friends, so he's super popular among his friends. So John Luke is a little socially aloof, so he has only 2 friends. So we had to somehow figure out how to combine these two guys together, Jean-Luc and Will, because they both have the same age, and we have to find out the average of the friends, yeah, and so on and so forth for the remaining friends in the remaining people in the data set as well. So let's look at some code, how to get started. Well, first of all, we need to parse away the data we need and throw away the data which we don't need. So basically we have to parse the file. So that's what we are going to use our parse line function here. Given a line of input data, we have split it up based on the comma characters which is found in it, and we are going to access field number 2 and 3. Mind it that this is a 0th index base, so basically so that is the reason it is 2 and 3, but actually this is 1 and 2 field, basically the first and the second field.
That field number 2 to an integer.
So basically this is a 3rd and 4th field, my bad, sorry. So the age, the 3rd field will be considered as the age, which will be converted to int and will be named as age, and the 4th field would be named as number of friends, and which will be also a friend indeed, number of friends variable, which will be stored in the number of friends variable. And what we return is a tuple, is a key value pair of age and number of friends as shown here. So that's the tuple. Note that we have completely discarded the user ID and the username of the input data, because we are aggregating the number of friends, so we don't need those data. So we have parsed, we are not parsing those fields. So basically I can say that this is not relevant to the problem which we are trying to solve. So basically we want to calculate the average number of friends for a given age. So who these people are doesn't matter for us. So once we are done with this, basically we take the file like sc.txt file and we load in our raw data using the map function and the using the function which we used, parse line. So with this, from our input data we landed to an output which is a key value pair RDD of age and number of friends. So we see the ages of the number of individuals, and we also see the number of friends in the tuple. So still we haven't yet done anything to aggregate the data yet, so we will do that very shortly. So what we have done is we have created a key value RDD in preparation for the operation which we are supposed to do in the next steps. So now what happens, things get a little bit complicated now. Basically it looks a little fancy here. Take a look at this big line of code here. It's a little bit intimidating, but it is indeed a common practice in Spark to write a code like this. Basically we are chaining the things here, chaining the functions here in this manner. If you look at it, we are actually taking the RDD, the key value pair of the ages and the number of friends, and then we are calling map values on it to transform the values of each one, and then we are chaining together with another operation on top of that with dot reduce by key. So So basically what this is saying is start with the age and number of friends RDD of our input data, and then we are going to map that with using the function here and take the resulting RDD from that step and then apply reduce by key on that RDD in as well. So basically we are doing two steps as one here. Pretty common to see, but let's break down to further so the first part is like rdd.map values using a transformation function of x transform to x comma 1. So all we are trying to do here is transform each number of friends to a tuple that contains the number of friends to the value n with the value 1. So what is the method of our madness here? Why I am adding a number 1 to number of friends? So remember, we need to have an average number of friends at the end, which is our end goal. And to compute an average, we need two numbers for sure. You need the grand total and you need the number of instances, the things which you added up, and divide those two things so as to get the average. So thinking ahead a little bit now, what I am going to do is transform all of these key value pairs of age and number of friends, a slightly more complicated format here where the key is still the age, whereas the value is the tuple itself, that is the number of friends and the value 1. And you see what happens when I try to add all these together. So when I add both fields of these tuples for each given key, I will end up with both a grand total of how many friends in total all 33 years old in the world had, and also I end up with the number of 33-year-olds in the world because I add up all those ones in each individual. That's what I'm trying to do here, and that's what reduce by key does. Because I add up all those all those ones for each of the individuals I saw. That's what I'm trying to do here, and that's what reduce by key does in the next clause of this expression. So that's gonna take two of these values, okay? So remember, reduce by key x and y is not a key value pair, but rather they are two different values. And in this case, the values are two different tuples here. If you see here, they're two different tuples, where the first value is the number of friends and second is the number of 1. I am going to apply this function where these are going to add them together, which is going to say the result will be the addition of the two number of friends coming in and the two number ones which is coming, okay? So as we keep running total of the entire data set, what we end up with is a grand total of how many friends in sum all the 33-year-old in the world of dataset have, and how many 33-year-olds are in our dataset, social dataset. And of course we are going to do that for every unique key automatically. Makes sense? Little bit complicated, but well, this is the most complicated thing we have done so far in the course. So if you do want to go back and stare at the slides again, definitely don't be afraid to do so. I'll not judge you based on that, because I also do that many times. No, so the next thing which we are going to do is actually use this information to compute the averages. So let's do it ourselves. So remember, at this point we have the key value pairs, and wherein keys are the ages and these are the grand totals of the number of people and the number of friends of that age. All we need to do is now divide those two to get the averages. So that is exactly what this map values function does. It says for a given value, which in this case is one of these tuples, we are going to take just the first field divided by the second field to get our final result. So let's get on with it. So in this particular example for 33-year-old, so we might end up with 33. For the age 33, we are going to take the average of the value and map it. Divide these two fields. 387 divided by 2 makes it like a 193.5, and we end up with a result of 33-year-old. Average number of friends as 193.5. Not sure what half a friend looks like in reality, but let's not get down that route. Line of a thought, it's a little bit off the track. Finally, we need to collect our results, and remember, nothing happens in Spark unless we call an action in Spark. So we are gonna collect the results here into a plain old Scala object, and then we are going to sort it. And so again friends, so reduce by key will actually add the number of friends which is coming in. X1 Y1 would be like 385 and 2 for the key 33, and X2 plus Y2 would be the number of ones for this key, for this tuple, so which will be 2. So it will be like for key 33, and X1 plus Y1, which is this two different tuple values, and two different values of this tuple, of these tuples, so get added up. So the next thing we need to do is actually use that information to compute the averages itself. So remember, at this point we have the key value pairs, wherein the key are the ages and values are the grand total of the number of friends and the number of people of that age. All we need to do is divide those together by 2 to get the averages. So herein what map values function does this for us. It says for a given value, which in this case is one of these tuples, we are going to take just the first field and divide it by the second field to get the final result. This particular example is for 33-year-old. We might end up with age 33. Take out the value and map to just divide these two fields. 387 divided by 2, which comes to 193.5, and we come up with an end result of 33-year-old, an average number of friends of 193 and a half. Not sure what half a friend looks like in reality, but let's not get to that line of thought right now. That's a little bit disturbing. Finally, we need to collect our results and display it. So always remember, nothing happens unless we call an action. So we are going to collect the results here into a plain old Scala object, and then we are going to sort it, and then going to apply the print line command to each individual entry, and we get the final results that way. So with that, in the next video we will look at the actual code, and we'll deep dive in more. So don't forget to subscribe to my channel if you haven't done so, and if you like this video, do subscribe to my channel, and also feel free to drop me a comment in the box below, and stay safe during these times.